To be able to control the alarm system from anywhere in the world, we need a mobile application. We are going to show you in this video how to create such an application. For this purpose we are going to use App Inventor. App Inventor is used as the app builder for the IC2Cloud platform. You can get details about this tool on the App Inventor website, appinventor.mit.edu. Creating a mobile application has two phases. First, we start by creating the user interface. Basically, we have to place the controls we need on the screen. Using drag and drop, we place layouts, labels, buttons, and any other control we want on the rectangle representing the cell phone screen. This is a fairly simple process. You can create as many screens you want for your application. Second phase is to create the rules required to drive the user interface. For this purpose, App Inventor provides a visual language easy to learn and use. Using drag and drop, you can place code statements as a puzzle game. Now let's get back to our application. The goal is to be able to do three things. 1. See on the screen the state of the alarm, if it's on or off. 2. See on the screen the motion status. 3. To be able to turn on or off the alarm. We start by creating a new project. We provide a name and press the OK button. Once we get to the screen, we start placing components on the screen. We need to create a vertical layout so we can place several rows in it. In the first row we will place two labels to show the state of the alarm. Second row will display the motion status. In the third row we will place two buttons. One to turn on the alarm and another one to turn it off. Now let's watch for half a minute how the process works. Basically, we drag layout components to get proper arrangement. We also place labels that will later be replaced with the words alarm and motion. We also place another two labels that will be dynamically generated with information retrieved from the wiring cloud representing the state for the alarm and motion sensor. We will also place the two buttons I mentioned before. Now let's accelerate the video to the point where the user interface is finalized. Once the user interface is finished, we need to set up the connectivity. For this we use the web components in App Inventor. We drag and drop them on the screen. These are not visible components. They represent HTTP calls that we will use to execute API calls to the wiring cloud. We need 5 web components. 1. Get the alarm status. 2. Get the motion status. 3. Set alarm on. 4. Set alarm off. 5. Reset motion status. What URLs you have to set for all these components is documented on the IC2Cloud website on the page dedicated to this application. On top of the web components, we also have to add a clock component. This is actually a timer that we will configure to trigger every second. We will use that trigger to read the alarm and the motion state. You will see how this is done in the coding section of the app building process. Once again, let's accelerate to the point where the web components and the timer are set. At this point the user interface is ready. We need to do the coding that will execute the necessary actions, read the values of the alarm and motion signals from the wiring cloud every 1 second, submit the on or off commands when the buttons are pressed. The coding is done by dragging statements on the working area. We start by specifying what has to be done when the screen of the application initialize. Basically, we make calls to get the status for the alarm and motion from the wiring cloud. Next step is to create two variables to store this information. We create a variable called motion and another one called alarm. We initialize them with n/a, not available. We also need the code to process the response to our API calls. Part of this code is to store the response in the variables we have created and also display the result on the screen. Let's watch for a while how the process works. App Inventor has an extensive set of functions you can use to create any specific functionality. You get text-specific functions. You get math, logic, lists and many other functions. To learn more about this, please read App Inventor's documentation. Because App Inventor is not fully integrated with IC2Cloud platform, you have to do a bit of processing on the response coming from the wiring cloud in order to get the response values. The wiring cloud returns responses in a CSV format. Each row returned contains the name of the requested signal and the value separated by a comma. As a result, we use split function to transform rows in lists of two elements, name and value. And we also use select item from list function to extract the second element representing value. Please be aware the result from this processing still has a return character at the end of the value. For our purpose, that is not important. We just use the result to display it on the screen. Once all this processing is done for the alarm signal, you can just duplicate the code and adjust it to work for the motion signal. Because we would like to have the motion and alarm signals refreshed constantly in the event they might change, we will use the clock component we have created to trigger an API call every second for the two signals. The processing of the results of this calls is done by the same code we just created before. Now that we have in place all the code necessary to monitor the alarm and motion signals, we need to add the code necessary to turn the alarm on when the button on is pressed. For this, we just drag the click event and we add the reset motion API call and the set alarm on API call. Once that is done, we do the same for the off button. When you finish this, the mobile application is ready for deployment. Just press the build button in the menu and select to use the QR code. From your Android phone, you can use the QR code to download and install the application on your device. You will be able to turn the alarm on or off and monitor the motion signal. Use the Signal Viewer tool from IC2Cloud website to check if the application works properly.